Good morning. Today we are going to see what is probability and what is random variable and how random process is associated with it. So, according to layman approach, probability is nothing but a chance. If there are if there is a chance to win a match, then it is coming under. Whenever we speak of chance, we discuss about probability. This probability has wide range of application in our day-to-day life. And here, mathematically, the probability is defined as number of favorable cases divided by total number of exhaustive cases. For example, when you consider tossing a fair coin, unbiased coin. Here we know that there are two outcomes, head and tail. So the total number of exhaustive cases is 2. And next is we are looking for the number of favorable cases. So the number of favorable cases for getting ahead is 1. So it is 1 by 2. So the probability of getting ahead is 1 by 2 and the probability of getting a tail is also 1 by 2. Let us consider another example when a fair die is thrown. Here when a fair die is thrown, hope all aware that the total number of exhaustive cases is 6. And if you look for a number, either it is 1 or 2 or 3, and for example, consider the number 4. The probability of getting a number, the chance for the number 4 is only 1. So, the probability of getting a number 4 is 1 by 6. Now, let us see some other examples. Every day sun rises in the east and we know that it is universally accepted and it is coming under sure event and the probability of a sure event is always 1. And next is it is possible to live without water and we know that it is not at all possible and it is an impossible event so that the probability of an impossible event is 0 and probably Arjun gets the job. So this is there are two possibilities. He may get the job or he may not. So the probability is coming under 1 by 2. Then next we the notation to denote the probability of success it is P and the notation to denote the probability of failure is Q and the probability always lies between 0 and 1 so that this P plus Q equal to 1 addition of success and failure is equal to 1 and Q is obtained from this expression as Q is equal to 1 minus P. And we discussed earlier, probability of sure event is 1 and probability of an impossible event is given by 0. And let us have some laws of probability. And the first one is addition law of probability. If you are looking for two events A and B which are not mutually exclusive. Mutually exclusive in the sense there is a chance that there is a coexistence of the two events. Then this probability is P of A union B is equal to P of A plus P of B minus P of A intersection B. Suppose if they are mutually exclusive. Mutually exclusive, the occurrence of one event is independent of the occurrence of other event. So in this case, P of A union B equal to P of A plus P of B. That is if the event A occurred once in a place, then the event B will not happen. For example, you are sitting at the class and you are at the home. It is not possible at the time, at simultaneously. Then when you look for independent event, tossing a fair die and tossing a fair coin, these two are independent events. Then next you look for multiplication law of probability. For the case of independent, P of A intersection B is given as P of A into P of B. These two events are independent. So tossing a fair, when you consider tossing a fair die as A event and tossing a fair coin as B event, the two events are totally independent. So in this case, P of A intersection B as P of A into P of B. And next, look, we are looking for dependence. So in this case, P of A intersection B is P of A into P of B given A. For example, in a bowl, there are 10 balls, and out of 5 balls are red and 5 balls are black. And you are drawing a black ball and you didn't return back the black ball. So, the probability of getting a black ball is 5 by 10, and I didn't return the black ball, and I am going for the selection of red ball. There are 5 red balls and only 9 balls, since I didn't return the black ball, so it affects the total number of exhaustive cases. So the probability is defined by 5 by 9. This is the case dependency comes. So P of A intersection B is equal to P of A into P of B given A, or P of B into P of A given B. And from this you can able to write what is P of A given B. That is conditional probability of A given B. It means probability of the event, occurrence of the event A, the event B has already happened. This is same. The selection of B is, that is black ball is already happened, and what is the probability of getting the red ball? So this is coming under P of A given B. Since selection of red ball is coming under A and selection of black ball is coming under B. So P of A given B is defined as P of A intersection B divided by P of B. And similarly P of B given A is defined by P of A intersection B divided by P of A. And here let us see some of the notations to go with probability. Probability of at least one event or A event is denoted by P of X greater than or equal to A. Minimum A event will happen. So greater than or equal to A. Then at most A B event, it is given by P of X less than A. Then P of X greater than or equal to A is given by 1 minus P of X less than A. P of X greater than or equal to A is given by 1 minus P of X less than A. Then let us go for introduction on random variable. So before getting into random variable, you should know what is a sample space. So what are all the possible outcomes in any event is called as sample space. I might have defined it in when we define probability itself. So the in probability, when you give the total number of exhaustive cases, it is nothing but the sample space. So when you toss a fair coin, it is H and T is the sample space. When you toss a fair die, the number of outcomes 1 2 3 4 5 6, this is coming under the sample space. So here in the sample space, here instead of using letters, if we assign numerical values, this is coming under random variable. So a random variable is defined as a rule that assigns numerical values to the each possible outcome of the random experiment. And this is also assigning numerical values to every possible outcome of the random experiment. So in this sample space, I am going to assign number 1 for H and number 0 for tail. So this 1 and 0 defines the random variable. This is also called as stochastic variable. And consider the experiment of tossing a coin twice. So let capital X denotes the number of heads in the outcome. So when you toss a coin twice, what are the outcomes? HH, HT, TH, TT. And the random variable associated with this, there are two heads, so it is 2. Here one head, it is 1, and here it is also one head, it is 1, and there is no head, it is 0. So this is how we are going to define a random variable. So you might have some question, why we need to define the random variable? It is enough to define like H, 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 T, T, H, T, T. So when it is, when the sample space takes some minimum quantity, minimum number of outcomes, there is nothing to worry. Suppose if the sample space contains large consignment of products, so in this case it is necessary to define the sample space in terms of random variable, that is in terms of the possible outcomes, in terms of the numerical values. And the probability, you know that the probability of getting a head is 1 by 2 and the head another head is 1 by 2, so it is defined as 1 by 4, and the probability of getting a head is 1 by 2 and the tail is 1 by 2, it is 1 by 4, and it is likewise it is defined. And let us see the types of random variables. There are two types of random variables. One is discrete random variable and another one is continuous random variable. So when do we look for discrete random variable? When the outcomes of the sample space is finite or countably infinite. Then we look for discrete random variable. Whenever the outcome is countable, then we look for discrete random variable. For example, a number shown when a die is thrown. And the another one is, this is for countable, and the number of alpha particles emitted by a radioactive source. This is for countably infinite. And now let us look for continuous random variable. A random variable is said to be, when it is said to be continuous, it takes all the possible values in an interval, and the value may be finite. For example, height, weight and age of individuals. When you speak of height, why I am saying this height as my example of continuous random variable. Even though height is a number like a numerical value like discrete 5.5 centimeter and weight as 65 kg like that, even though it is defined discrete and this is defined in some range, the range, it is the height lies between 5 to 6 feet and the weight lies between 60 kg to 70 kg. So it is defined in some interval and in that it takes the possible values. So this is coming under continuous random variable. And for the discrete random variable, the probability is given by the probability mass function. So x is a random variable which can take the values 1 to x1, x2, etc. such that p of x is equal to xi equal to pi is called the probability function or probability mass function with the condition probability lies between 0 to 1 and addition of each probability is equal to all the probabilities is equal to 1. And cumulative distribution function, we are looking for discrete case, it is defined as capital F of x is equal to cumulative, so it adds the previous and next it adds the next previous values. So p of cumulative, in the name itself you can understand it cumulates all the values. So p of x less than or equal to x is summation pi where xi less than or equal to x. Next we are looking for a continuous random variable, the probability is defined in terms of density function and it is f of x. P of x minus dx by 2 less than or equal to x less than or equal to x plus dx by 2. Since for continuous random variable it takes all the values in a range. The range is defined in some interval x minus dx by 2 less than or equal to x less than or equal to x plus dx by 2, and the probability density function is defined by f of x. Always we know that the continuous function is defined in f of x. And it also has some condition, f of x should be greater than or equal to 0 and the integral from minus infinity to plus infinity f of x dx is equal to 1. And you should note that the probability of for a continuous random variable, probability at a particular value, particular point equal to 0. And the next is probability a less than or equal to x less than or equal to b. For discrete case, this less than and less than or equal to matters, but for continuous case, it takes all the values in the interval. When the case of discrete, when it is strictly less than, you should eliminate a. You should not add for the calculation. You should not add a to the calculation. Similarly, when strictly less than b, you should not add b to the for the calculation. For a less than x less than b, here you should not add A and B. You have to take the intermediate integer values only in the interval for discrete case. But for continuous case, it takes all the values in the given interval A to B. So this less than or equal to no matters. And for continuous case, the cumulative distribution function is defined as capital F of x equal to integral minus infinity to x f of x dx. And the properties of the cumulative distribution function is f of the lower end minus infinity is 0 and the upper end f of infinity is 1, and the probability and the cumulative distribution function is also defined from 0 to 1 for x1 less than x2. This capital F of x1 is also less than capital F of x2, and the probability of using cumulative distribution function is obtained by f of b minus f of a. If you know only the cumulative distribution function capital F of x, then the probability is obtained by the expression f of b minus f of a. And here comes the relationship between probability density function and the cumulative distribution function. We know that the probability density function is denoted by small f of x and the cumulative distribution function is denoted by capital F of x. The relationship is small f of x is equal to d by dx of capital F of x. So with this idea, then this random variable introduction is over. Now we are looking for what is random process. So in associated with the random variable, if you assign time function, then this will leads to random process. Okay, hope this is useful to you. Thank you.